Welcome back to my YouTube channel. In today's video, I'm going to be talking about integration. In my former videos, I've been doing differentiation, chain rule, and other sort of differentiation. Integration is like the opposite of differentiation, like finding for the opposite form of differentiation. So let's say, for example, normally we have something like y is equals to x plus 2. So we have to find for the y, the x is equals to whatever that this will give us. Let's say 1 or whatever. But let me know something this simple. Let me use something like x squared plus 2x or whatever. When we differentiate this, we have 2x plus 2 as our answer if we are differentiating this. But integration is like finding for the reverse form of integration of differentiation. So if we are finding for the reverse of this, we are going to put this sign here. This sign here is what is making that is representing differentiation. So we put this sign here and put this sign here. So when we put this sign here, this one automatically becomes y, and integration of this. Now this is where we have to know the basic formula of integration. So now if we say y is equals to x raised to power n, and then when we now differentiate it, we get something like n times x raised to power n minus 1. So how do we convert this back into this? Well, that is simple. So we just add 1 to this place. We, in order to get y back, we add 1 here. We have n raised power x plus n minus 1, which we would have already gotten the n minus 1 as a particular value like this. Then we add plus 1 to it. Then divide everything by whatever that was there before plus 1. Everything here is going to end up giving us something like n raised power x raised power n all over n, where n cancel n, and we finally have our y back. So therefore um the the basic formula for integration is when we are integrating x raised power n, then it is equals to x raised power n plus 1 divided by n plus 1. This is the formula for integration, as simple as that. So we are going to be applying this formula here into this place. So applying the formula here. Now, first of all, we have 2x plus 2. We can put it in separate sides. We can simplify it as integration of 2x plus integration of 2. We can put it this way. So now, integration of 2x, when we are integrating 2x, it will be equals to 2x. Now we know that x is here, x is raised to power 1 because it's not showing. X is raised to power 1. So we have x is power 1 plus 1 divided by 1 plus 1 plus, in this other place we have 2 here. 2. Now we know that there is no form of x here at all, and for there to be no form of x there, if we are to put x there, that means we are having something like x raised to power 0, because x raised to power 0 is equals to 1. X raised to power 0 is equals to 1. If we find x to power 0 is equals to 1, and 1 times 2 will still give us 2. So we can just imagine that the 1 that is multiplying the 2 is x raised to power 0. So we have 2 times x raised to power 0 plus 1 divided by 0 plus 1. As simple as this. But in case you do not want to be going through long step in this second part of this place, you can simply put it as wherever you find a constant and you are integrating a constant with respect to x, you just simply put x at the back. We have 2x. If we had actually followed the former method, which is a bit longer, we would have gotten to 2x, which we got 2x is power 0 plus 1 divided by 0 plus 1. We will have the same thing as 2x. So now let me simplify the other ones we have here. This is equals to 2x raised power 1 plus 1 is 2 divided by 2 is equals to plus 2x. 2 here will cancel 2. We have our final answer as x squared plus 2x plus c. Let me write it in a bigger platform. Our final answer for this is x squared plus 2x plus c. Now, why is there c here? Why is there c in this place? Whenever you are integrating, it is always compulsory for you to put your constant c. The reason be because let's say we have something like 6 at the end of the year when we differentiated it. If we are differentiating 6, it's going to end up giving us 0. But integrating 0, we will not actually know what the constant is. So that's why we put c here. It's always compulsory to put c. Now let me show you some kind of example that maybe you try to get why we are putting c here. So now let's say we have y is equals to x cube plus 5. X cube plus 5. If we had to differentiate it, that is not integration yet. This differentiation I want to show is whatever we differentiate that we actually have to integrate. So the differentiation of this is dy dx is equals to 3x squared. The 5 will become 0. This is the differentiation form. This is what it is. So now let's say in a question we have not seen this before. Inside the question they ask us integrate using this sign 3x squared. Now integrating 3x squared, we use our formula. We have 3x raised to power 2 plus 1 divided by 2 plus 1, which will give us 3x raised power 3 all over 3. 3 cancel 3. We have it as equals to x cube. Now our answer is giving us only x cube plus c, which is why I said we should always add our plus c. Now that plus c is representing in case there is something at the back here like plus 5, because we do not actually know. There is no how we can be able to get what 5 is. And even if they give you a question like this, we do not know whether it is 5 or not. We do not know whatever constant it is. We just know that there is always a constant. And even if there is no constant here, plus 0 will still end up giving us this. 0 is also a constant. So always remember to add your constant c here. So now let me go into a little bit of trigonometry. Let's go into a little bit of trigonometry. Now this will be a little bit twisted because it's not the same as differentiation. So we have y is equals to let me take something as simple as no, we are not differentiating here. They ask us to integrate with this sine x, integrate sine x. So now sine x, then they put a little bit of dx at the back here. So sine x is what we are going to integrate here. They now ask us integrate sine x. Now if we were to differentiate sine x in the table of trigonometric ratio, sine x y dy dx. Sin x is equals to cos x, right? Then cos x is equals to minus sin x. We have tan x is equals to sec, I think sec square x or something like that. This is something similar to this. So we have our y as when our y is sin x, the y this is equal to cos x. So this is for differentiation. Now we have this, then we differentiate it to give us what is at the other part of the table. But if we are going to be integrating, it's going to be the other way round. That is like if we are integrating, if we are in this is for differentiation, right? Differentiation, differentiation. Now integration, we have our dy dx, then we have our y. In order to convert the y dx into y, sin x is equals to minus cos x, and our cos x is equals to sin x, like that, and so on and so forth. If we have sec x, it will be something like square root of tan x, and so on and so forth. But these are the major two, that is the basic. Sin x is equals to minus cos x if we are integrating, and cos x is equals to sin x, unlike differentiation whereby sin x is equals to cos x and cos x is equals to minus sin x. So now I think I've already given the answer for that. So the integration of sin x here is directly equals to minus cos x. This is the answer. Now if you want to check your answer, for example, let's say this is y, you can differentiate this again. You know that when you are differentiating this, now don't always forget that whenever you are integrating, always put your plus c at the back. Let's not forget. So this is whatever it is. When if you differentiate this back, minus cos x, you are going to eventually get sin x. So that is integration. Integration is like the inverse of differentiation. So that is it.